Hello, year 10s. Isn't this gorgeous? These three puppies sharing a stick. And this picture always reminds me of our next type of bonding, which is covalent bonding. So let's get going from here. So covalent bonding, a lot of substances that use covalent bonding are things like what we have in air: oxygen, nitrogen, carbon dioxide, and all of these are non-metals. So that's the next thing I want you to remember with covalent bonding. It involves sharing, and it only ever involves non-metals. So let's see how this sharing malarkey works. So over here we've got two hydrogen atoms. They both had one electron in the outer shell. They would like to have two electrons in the outer shell, and because the first shell only has two electrons, by joining together and sharing that one pair of electrons, they form a single covalent bond, and that's why hydrogen is found in the form of H2, which is a diatomic molecule, two of the same elements joined together. Here's another example. Chlorine is in group 7, so it has 7 electrons in the outer shell, so it needs one more to share. So by sharing that pair of electrons in the middle, this shell here now has 8 electrons, and this shell here has 8 electrons. Note how they're using a dot and a cross to make that very, very clear. Another way that I can show this is by what we call a stick diagram. And over here you can see chlorine with the single covalent bond represented by a single line. That means one pair of electrons are being shared. There's some other examples that you need to know, and the syllabus doesn't require you to know an indefinite number, but the ones that they do mention, make sure you know, because they could ask you to draw any of these for a couple of marks. Notice in this one of oxygen, I'm only drawing the electrons in the outer shell. Oxygen, being in group 6, has 6 electrons in the outer shell. So if I count the pink one, I've got 1, 2, 3, 4, 5, 6 circles. So 2 of the 6 are going to need to be in the middle so we can share 2 of the electrons with the other oxygen atoms. So this time, rather than one pair of electrons shared, we've got 2 pair of electrons being shared, and that's why it's known as a double covalent bond. If we show this as a stick diagram, we show the 2 bonds by the 2 lines over there. Nitrogen and hydrogen gives us ammonia, and this is why we need 3 hydrogen atoms for one nitrogen atom, because nitrogen has 5 electrons in the outer shell, so it needs 3 hydrogen atoms to get a full outer shell. So we've got 3 single covalent bonds being shared. Now, perhaps you can pause and see if you can draw these. They might test you, or you might know this already. When you're ready, check your answers. Okay, so carbon dioxide is CO2 because this carbon has got 4 electrons, so it shares 2 with one oxygen and another 2 with the other oxygen, gaining 4 electrons. So now if I count, this oxygen has now got 8 electrons, this carbon atom has now got 8 electrons, and this oxygen atom has got 8 electrons. So I can very quickly see in the exam if I've got the answer right, or if I've got wrong, go back to the drawing board. Water. So oxygen has got 6 electrons in the outer shell, so the 7th and the 8th comes from sharing an electron with 2 hydrogen atoms, 2 single covalent bonds, hence the stick diagram looking like that. And this last molecule is known as methane gas. Yes, farts, delight. Okay, CH4. And in this one, The carbon, having 4 electrons in the outer shell, needs 4 hydrogen atoms to get a full outer shell. And if I draw it as a stick diagram, it's going to look like this at the bottom. So it's just practice and making sure you can count to 2 if there's a hydrogen involved, or 8 if it's any other element. Okay, so this is some basic information we need to know off by heart about covalent bonding. It occurs between nonmetals. It involves sharing of electrons between atoms. They have low melting points if they're simple molecules like oxygen. That's why oxygen is a gas at room temperature. But some covalent substances can be liquids or gases. They tend to be insoluble in water, and they absolutely do not conduct electricity, unless we talk about the giant covalent substance graphite, which is the exception to the rule. So they can form simple or giant substances. So oxygen and methane and carbon dioxide are simple structures. We'll look at the giant structures in a moment. So again, you need to be able to get the best results by explaining why. Why do simple covalent substances like oxygen have low melting and boiling points? Now the reason for this is because although there is a strong covalent bond between the carbon and the oxygen in carbon dioxide, the force between each individual carbon dioxide molecule is weak. So just like we have an inter-house competition, the intermolecular forces are very, very weak. And that's why it doesn't take a lot of energy to turn it from a solid to a liquid to a gas. Okay. So the last point I want to make here is that covalent substances do not conduct electricity. And the reason for that is because there's no electrons that can move around, or there's no charges like there is for the ionic substances. So because we know that electricity is the flow of current, the flow of electrons, if there's no delocalized electrons, we're not going to have any electricity. Now, the next thing brings me on to the giant covalent substances. And of course, for this picture, I have the Cullinan diamond, the biggest diamond ever found from South Africa, which was gifted to the royal family and is now in the Queen's possession. And then also made out of carbon, but not nearly as elaborate, is graphite. And because they're both forms of carbon, but they all carbon, but they're made in different forms, they found in different forms, we call them allotropes of carbon. So allotropes are different forms of the same element. Now, there are lots of allotropes of carbon that you need to be familiar with. Over here, this is what diamond looks like. Each carbon atom has got 4 carbon bonds joined to it. Whereas in graphite, if you look at this one over here, it's got 1, 2, 3 carbon atoms joined to that middle carbon atom. And the 4th electron forms a very weak force of attraction with the layer below. And that's why it's not as strong as diamond. We also have our fullerenes. They contain less carbon atoms. This will contain 60 carbon atoms in a ball. So we have Buckminster fullerene, or it can come across as a tubule, and sometimes they deliver drugs through these nanotubules. And graphene is a flat sheet of a single row of carbon atoms, and they can fold it. It's a very, very new, wonderful material that scientists are working with. But not all giant substances are made out of carbon. Silicon dioxide, which is sand, has this magnificent structure. And you can see the silicon atoms has got 4 oxygens attached to it, and each oxygen has got 2 silicon atoms attached to it to get this amazing structure. So you need to pause the video and read through these different properties of these different substances and the reason why they have those properties. It's important that you can recall this in an exam. It could very well be a 6-marked question.